Hello everyone, I'm Anant Mittal, the author of the book TMUA Simplified. So I'm bringing you this series, question of the day. So I brought two more questions, so let's do them. Okay, now in this question it says that it's a very classic case of finding three roots of a cubic through differentiation. Finding roots of a cubic through differentiation is what we will be uh, is what this question is all about, right? So equation is given to me and it says that this equation has three distinct real roots. Now they have mentioned it and they're asking us to find the range of k for which it will have three real roots, distinct real roots. Right. So if I look at a, the leading coefficient here is greater than 0. So if it is greater than 0, so it is necessary that it will come from, if I draw a graph of it, so it come from here, right? And if it has three distinct real roots, so this is how the shape looks like. Now this is not the actual graph. This is not even the position of the graph, right? The roots may be different, but it's just a graph for which a is greater than 0 and it has three distinct real roots. So this is the condition. Now how do we go about this? 2x cube minus 9x square plus 12x plus k, let it be y. Now I find dy by dx. I'm gonna differentiate the function. I'm gonna get 6x square minus 18x plus 12. And if I take 6 common, I'll get x square minus 3x plus 2. Now the roots of this, if I put it equals to 0, first derivative 0 gives me the point of maxima or minima, local maxima, local minima. So it will give me x equals to 2 and x equals to 1. Now, obviously, at 2, it will be, I can check also. If I if I find the value second derivative, if I find, so it gives me d2y by dx2 is 12x minus 18. So at 1 it is negative, so 1 is a point of maxima, and at 2 it is positive. So it will give me at 1 the second derivative, I mean the second derivative is negative. So if I put 1 here, it gives me a negative value. So that means it's a point of maxima. And at 2, it gives me a positive value if I put here. So it's a point of minima. So at 2, there is a point of minima. At 1, there is a point of maxima. It's like this. So at 1, it's a point of maxima. At 2, it's a point of minima. So I can draw a curve like this. Now for it to have three distinct real roots, I know that at 2, the value of the function should be negative. Right? At 2, the value of the function should be negative, and at 1, the value has to be positive. So this is what I need to address. So now, if I put 2 in the function, right, I'm going to get 2 into 2 cube, that is 16, minus 9 into 4, 36, plus 12 into 2, 24, plus k needs to be less than 0. Because f of 2, the value has to be negative. It has to cross the x-axis and go back, so it will be a negative value. Below the x-axis, it's a negative value. So this gives me 60, this is minus 20 plus 4, 24. Minus 20 is k plus 4. K plus 4 is less than 0. So k is less than minus 4. And at 1, the value has to be positive. So 1, it will be 2 minus 9 plus 12 plus k should be greater than 0. At 1, the value has to be positive. So k is greater than, uh, this is 14 minus 9, 5. So greater than minus 5. So if I combine both the cases, right, is it, just a minute, 40 minus 36, yes. Finally, I have an option, right? So my k is greater than minus 5 and k, combining both of them. So k will be greater than minus 4, sorry, less than minus 4 and greater than minus 4. This becomes my correct answer. So, very common question in TMUA. Then there can be, now you can work around, okay, what can be the values of k for which it will have exactly two roots, two distinct roots, or one root, one real, two imaginary. So all those cases can be verified through this method only, right? Okay, let's move on to the next. Now it says that this is a graph given to us, but this is not the graph of fx. This is the graph of f dash x. Now they are saying from -3 to 4, right? -3 is somewhere here, 4 will be somewhere here. In this range, I have to find out how many stationary point and how many point of inflection will be there. The graph is not of fx, it is of f dash x. But I know that when f dash x is 0, then there will be point of local maxima or local minima. So it is 0 at 3, it is 0 at 1, and 0 at -2. Now the only thing which I need to ensure is that f dash, the sign of f dash x on either side of these 2 points should be different. If they are different, so all these three are stationary points, either a point of local maxima, local minima. That also I can test which one is a local maxima, local minima, but that this question does not demand that. So I have to just check whether on the on the either side of these points where f dash x is 0, the sign should be different. I can see it's positive here, it's negative here, it's negative here, positive here, negative here, positive here. So yes, so three stationary points are there. And if I differentiate this function again, so I'm going to get f double dash x. Now f double dash x is 0 where the tangent is parallel to x axis. So in the f dash x graph, wherever you have a point of maxima or minima, right, for f dash x, those are the points of inflection for the original function. So there are 2 points of inflection. So we have three stationary points and 2 points of inflection. So C is the correct answer, right? So C becomes the correct answer. So this is how we can go about this question, right? So I hope you found these two questions very useful, right? For more such questions, you can buy my book, that is TMUA Simplified. The link, it is available on Blue Rose publication. I would prefer you to buy from there. Reason being, it will be a little quicker than Amazon or Flipkart. You can buy it from there as well, right? The links are in the bio, right? So again, in the previous video, I've said this something. Now again, I'm saying the same thing, that the book costs only 4,000 and includes all theory video and solution videos, right? Rarely you'll find it somewhere, right? The cost of the book is 4,000. Otherwise, for such videos, the coaching institutes, they charge in excess of 60, 70,000, right? So watch out for more videos, right? Till then, take care. Bye bye.